Hello students. So in electricity the next topic is electrical energy. So we have studied about electric power, that electric power is the electric work done per unit time. And what is energy? Energy is the capacity of the body to work. So if we go by the formula, electric power is equal to work done by electric current upon time taken, and taking in consideration that work done is nothing but the electrical energy consumed, so we can get that power is equal to electrical energy upon time. So from here we get the formula as electrical energy is equal to power into time, or E is equal to P into T. Now there are various formulas for P, such as P is equal to VI, P is equal to I square R, and P is equal to V square R. So we can replace P by VI, or P by I square R, or P by V square R, and we can get various other formulas like E is equal to VIT, E is equal to I square RT, and E is equal to V square by R into T. So there can be many formulas as we discussed in electrical power as well. If you want to see, here you can check that P is equal to VI, P is equal to I square R, and P is equal to V square R. So we can just replace the E is equal to P into T by the formulas, and the unit is power is in watt and time is in hour, so we can say the unit is watt hour. Or if you take time in seconds, then it is watt second, or you can say it as a joule. If we talk about the commercial unit of energy, we know that watt second is a very small unit, or you can say watt hour is a very small unit, because we use various equipments in our home whose ratings are quite high. For example, refrigerators, ACs, geysers, etc. So if we go on calculating the energy in joule, it will be quite hectic. So what we do is we take some unit by keeping in standards, and the unit here is 1 kilowatt hour, which is nothing but 1 unit. So what you see in our at our home, that the electric a person who comes here for the electric meter reading, so what he captures the reading of the meter, that 1 unit, 2 unit, or 100 unit. So those 100 unit means 100 kilowatt hour, because 1 kilowatt hour is what? It is 1 unit trip of meter. So 1 kilowatt hour is 1000 watt into 1 hour, or you can say 1 kilowatt hour is the amount of electrical energy consumed when an electrical appliance having a power rating of 1 kilowatt, or you can say 1000 watt, is used for 1 hour. So simply you can multiply watt into hour and change into kilowatt hour by multiplying by 1000, or you can change the watt into kilowatt by dividing by 1000 and then multiply into hour. So you can see here 1 watt is 1 joule per second, and 1 kilowatt is hour. If we talk about, then 1000 joule per second, and if we change hour into seconds, that is 60 into 60. So 1 kilowatt hour becomes 36 lakh joule, or 3.6 into 10 to the power 6 joule. You would have already learned this conversion in class 9 as well. So the formulas that we look was E is equal to P into T, and we know power is nothing but voltage into current. So we can write E is equal to VIT, and if we replace V by various formula like IR, then it become I square RT, and if we replace I by V by R, we get V square T upon R. So these are the various formulas, and if we go with the numericals that comes onto this formulas, then let us see an example. So two bulbs, one rated at 40 watt and 220 volt, and the other at 60 watt at 220 volt, are connected in parallel. So you can say that two bulbs are connected in parallel, and the rating is given. Rating is what? The energy that the bulb consumes. So by 40 watt means that it consumes 40 joule per second. By 60 watt we mean 60 joule per second. So what we have to do is we have to make a circuit diagram of this, that 40 watt and 260 watt in parallel, and the voltage supply is 220 volt. Then after we have to see what is the current drawn from the circuit, and after that we'll calculate the total energy consumed when it is operated for 1 hour. So this is the symbol for bulb. This is the symbol for bulb. So the first bulb is rated at 40 watt and the second bulb is rated at 60 watt. So here what we have done, we have arranged both the bulbs in parallel. So parallel connection, and the parallel connection, the supply source is 220 volt. Now if 220 volt is the supply, then the total current that is supplied by the 220 volts potential difference would be I, and this I would distribute into I1 and I2, because we know there are two arms and this current will break in two arms. The higher the resistance, the lower the current, the lower the resistance, the higher the current. So if we have this potential difference, we have what we can calculate various other things. So let us go with the next question, that is we have to find the current. So if we have to find the current, we know that formula P is equal to V into I. So from P is equal to V into I, we have taken the first bulb power, that is 40 watt. So 40 watt is equal to 220, that is the supply voltage, and I1 will be the current. So it came to be 2 by 11 ampere. Similarly for the 60 watt, we again put in the same formula, that 60 is equal to 220 into I2 will get 3 by 11 ampere, and the total current I is equal to I1 plus I2, that is 5 by 11 ampere, or if you change you will get it as 0.45 ampere. Now this could have been taken out by various other ways. You could have find the resistance, and then after you could have find the current. So there are various formulas. If you put it in any of the formula, you can get any value, and by that value you can put in other formula and you'll get the value of current. So what I have done is, when I have to find out the energy, I have tried to take it down in two ways so that you can understand. So first of all, what I did here is that we have to find what is the energy consumed by both the bulbs. So what I have done is I have taken out the energy by first bulb, energy by second bulb, and then after taken the total energy. So if you see here, E1 is, that is 40 watt, the energy consumed by 40 watt bulb will be power into time. So the rating is 40 watt and the time is 1 hour. So 1 hour is equal to 3600 second, that is 60 into 60 second. So I have multiplied E is equal to P into T, power is 40 watt, time is 60 into 60, that is seconds. So it came to be 144,000 joule, that is 144 kilojoule. Similarly for 60 watt, I have done is power is 60 watt and time is 60 into 60 seconds. So it came to be 216,000 joule, that is equal to 216 kilojoule. So total power come to be E1 plus E2, that is 360 kilojoule. But we could have directly find out what is the value of energy, and by the formula here, if you see, we know energy is equal to power into time, and what is power? Power is equal to V into I. So we can write energy is nothing but voltage into current into time. So voltage, supply voltage is 220 volt, the current is 0.45 ampere, and the time is 16 to 60 seconds, that is 3600 seconds. So if you multiply, we'll get 35,000, we'll get 3,56,400 joule, and if we'll change that, we'll get 356.4 kilojoule. So you can see this is quite near to that 360 kilojoule. And why there is difference? Because we have seen here that 5 by 11 ampere. So this 5 by 11 ampere 0.45 is not the actual value. So there is some variation, but if you round up the value, that is 356.4 kilojoule, you'll get as 360 kilojoule. Let us see other example. So here a 2 kilowatt heater, a 200 watt TV, and 3 bulbs of 100 watt all are connected and are operated between 6 p.m. to 10 p.m. So what is the total cost of energy that is being used? Means you have to take out how to find out the bill of the particular home which is using these instruments. So you can see there are 3 instruments. There is one geyser. So let us take power of the geyser to be 2 kilowatt. There is one TV, the power is 200 watt. What I have done is I have changed directly into kilowatt because I have to find out the reading of the reading. Then after I have to find the cost of the electricity. So what I have done is I have changed everything in kilowatt. So P2 is 200 watt, that is the rating of TV. Now there are 3 bulbs. each of 100 watt. So one bulb of 100 watt, so 3 bulb will be 3 into 100 watt, that is equal to 300 watt. So the rating come to be 0.3 kilowatt. What we do is divide by 1000. So total power rating come to be 2 plus 0.2 plus 0.3, that is equal to 2.5 kilowatt. So this is the total rating of the home. So if we see what is the hour of operation, so 6 p.m. to 10 p.m. So that means it is operated for 4 hours. So you have time, you have power. By the formula E is equal to P into T, you will get what is the commercial unit of energy consumed. So E is equal to 10 kilowatt hour. Now the 1 kilowatt, you should know that 1 unit is equal to 1 kilowatt hour, and so therefore 10 kilowatt hour is equal to 10 unit, and cost of 1 unit is rupees 5.50. So 10 it will be 5.50 into 10 is equal to rupees 55. Similarly, what you can do is you can see the ratings of the various equipments that you use at a home, and if you know what is how much you are using that equipment, then you can directly multiply the rating into time, and you will see what is the energy consumed by that particular equipment. And if you change that in kilowatt hour, now what you can do is just add the total rating and you will know what is the electricity bill of one day, and if you multiply by 30 you will get 30. If the month is of 30, you will get the reading of 30 days, and similarly you can find out the bill of 30 days. So what we'll do is in next class we'll see more numericals, and then after we'll see heating effect of electric current. And what is very interesting is that this heating effect of electric current is having same formula as that of energy. So till then, thank you and stay safe.